Everybody who's watched my Hyundai series understands that I've battled this wiring harness ever since this car first showed up here. First the O2 sensor circuit burned up, then several shared sensor grounds went bad, now the ECU connector pins keep open shorting. This 30-year-old harness has been on fire, bathed in coolant, oil, and hydraulic fluid. It's on its 6th build and its 3rd car meow, and it's been cut up more than a magazine in Jussie Smollett's living room. So what you're seeing here is the beginning of something that no mechanic ever wants to have to do. I'm going to make a new engine harness. I know what most of these connectors are, even without using the information that I've gathered, but tagging everything is always a good time-saving practice. Not including the grounds, there are 31 total connectors on a DSM harness, and some of the plugs are the same, but not all of them have something plugged into them. This is especially true in my case. A whole lot of equipment is missing from this car, but I also have several aftermarket sensors that I'd absolutely love to add to this engine harness just to reduce clutter, and I will. I feel like my efforts suffering through this job yet again for all of your entertainment will ultimately help all of us because it'll shut up half my excuses on track day for why I have bad logs. But I gotta remove its central nervous system first to show you what I'm starting out with. Now that the harness is out, I need to gather my materials and have an organized place to work. There's a lot going on when you're making your own engine harness. A whole lot of stuff to keep track of, so everything that you do to make this easier on yourself can save you a whole lot of time and headaches on an already annoying job. I needed a few things that I don't currently have. I'm making a wire rack out of 4 32-inch lengths of 2x8s, 3 3-foot lengths of 5/8-inch all-thread, 6 nuts, 6 washers, and 8 3-inch deck screws. Including the width of the lumber, that gives me an inch of overhang on the all-thread for a ½ inch to put the nuts on. I ended up with 96 linear inches of wire storage. It's a little bit more than I need, but I've got room for expansion now. For $20 more, I could have bought one with 10 more linear inches of storage and waited for it to show up, but this took 20 minutes to build with local materials and it saved me $20 just to make it myself. It's not complicated. Now that it's mounted securely, let's go ahead and load it up. I bought the 1G ECU connector kit from Ohm Racing. They offer brand new ECU harness connectors, which is fantastic. That covers one end. And this is the 1990 base harness connector kit from Sheridan Engineering. It's everything you need for the basic necessities on the other end of the harness. Probably going to need some needle nose pliers at some point. The crimp tool for the ECU pins and some of the harness connections is insanely expensive. You'll need wire strippers too. The GM weather pack tool, since I've got some GM connectors mixed up in there. I've got the ratcheting crimp pliers specifically for solder seal waterproof shrink connectors, and of course the 250-piece assorted set of the connectors that go with those pliers. I picked up the bare GM connectors for the manifold absolute pressure and intake air temperature sensors. You'll remember that I ditched my mass airflow sensor and converted this car to speed density, so instead of using a 5-foot adapter harness, I'll be wiring these straight in wherever they go on the harness just to clean things up. I also decided to pick up a flex fuel connector to play with in the future. It's sad that I needed so few and specific things because Racetronics had some really cool stuff that's all way too nice for my Elantra. All the wire on that rack is PVC shielded automotive wire. PVC is not very resistant to heat, but many manufacturers like Mitsubishi and Hyundai still use it to make their harnesses. Alternatively, GXL or TXL wire works better in harsh environments like engine bays, so the bulk of my wiring will actually be done with this wire instead. I want to take a minute to talk about my wire selection, why I bought what, and what the ultimate goal is here. This is the ideal layout of the factory engine harness circuit for my engine. You'll find this in your engine's factory service manual. Using that manual, anyone can identify, trace, test, and repair an electrical circuit. Anyone. You might have no clue what any of this means, but the earlier sections of your service manual explain every last number and symbol on this chart. It documents everything in extreme detail and simplicity. So if you have no idea what this is and you landed on a page that looks like this, just turn back to the beginning of the chapter and it's all right there. It gives you all the color codes and tells you your default wire thickness for your engine. It explains how the diagrams are notated whenever a different thickness wire is used. It tells you what pin of what connector it's terminated on, the gender of the connector, and where it's located. It shows you where your ground circuits are and what wires have RF shielding on them, how to determine if two circuits are joined by a junction in the diagram or not. So your service manual is what you need before you do any of this hunting and gathering. It won't tell you how long the wires need to be. That's my job to figure figure out, yes, I have way overbought my materials by probably about 4,500 feet, probably enough to do 3 or 4 cars, but I wanted to ensure that I'd have everything I needed of whatever wire color and size required to leave me with a harness that I can still troubleshoot. It won't be perfect, but one that still matches this diagram is what I'm going for. I had an impossible time finding striped wire, so I decided to see if anyone made a tool for striping the wire. I searched. Turns out there's no such thing as a wire striper. Not in a spool, not in a tool. I could not, would not, in a pool. Not a one on all of the internets. Seriously, Google will not even ask you if you made a mistake. You'll only find every kind of wire stripper under the sun. Maybe that might change someday, because I see a void that needs to be filled. One that's going to make me rich. That's why I'm telling all of you about my big idea. We'll just keep this our little secret, okay? I'm going to need all of you to go click the description and go down there where you'll see a non-disclosure agreement link. Go sign that. Alright, we'll move on with this. I used a piece of Schedule 40 half-inch PVC pipe, chopped it off at 8 1/8 of an inch, and punched a 1/4 inch hole in it. I grabbed a 1/4 inch roll pin and made some modifications to it. First I drilled a 5/32 inch hole, and then I cut it lengthwise, halfway down, using a cutoff wheel. The split makes it fit more easily into the hole, and it helps me clock and center it in the pipe. I used a couple of half-inch couplers. Get it? Eh? A couple of couplers? I pounded those on both ends of the pipe, and I set off the neighbor's dog. Let me line this thing up here. I also bought 2 half-inch plugs and 2 sets of paint markers, including all of the primary colors. Paint markers have a valve in the nib that opens with pressure, allowing paint to flow. So first I'm going to get the paint flowing. The hole in the roll pin allows the nib to touch the wire, but the hole is not bigger than the nib. I built this thing to snugly fit the outer diameter of the paint markers and to be just long enough that compressing the plugs into the ends of the pipe opens up the valves in the paint markers so that it can keep flowing. Now that it's loaded with freshly primed paint markers, just feed it a wire. And there you have it, a striped wire. I can corner the market on wire stripers. The harness manufacturer probably has some $3 million machine that does this, but mine is under $7 in materials. The acrylic paint doesn't dry instantly, but it doesn't take very long. Just be aware of that so you don't get it everywhere. Even if this just lasts long enough for me to put a harness together, I'm happy with that. Now back to show and tell. I had a pair of these that got launched into the woods from frustration. I wasn't the one that did it, and it made me sad, but I got over it. To go with those GM connectors, I picked up some Delphi Crimpers that you're supposed to use. They're different than all the other crimpers used elsewhere on the harness, so gotta have them. It's nice that my supplies and tools are organized, but I need a space to work on the harness. The dinner table's not going to work well, so don't get yourself killed by the missus. I bought 5 8-foot 2x4s and a sheet of Sureply. I'm building a cheap table frame. I was going to do this on a pair of sawhorses with a sheet of OSB on top, but the sawhorses were 22 bucks a piece. OSB sucks, and it would have been about 60 bucks to do this just to get your work about 3 feet off the floor. Sureply has a finished texture, which is great for writing on. It's strong enough for what I'm doing, and it beats a concrete floor. I get to stand up straight and work comfortably. That's important to me because I'm going to be here for a while. I'm flipping this thing over and putting 2 more deck screws from the top into each leg just to make it a bit more rigid, and then skinning the table frame with the Sureply. Just for the record, a 49.5-inch table is too tall even for me. I'm knocking 8 more inches off these legs so that it's waist height. Now, I have a disposable 8-foot table to do all of my harness layout on. It's smooth, semi-absorbent, and I can destroy it. Cheaper than an 8-foot table from an office supplier. If I were making a copy of a harness, I'd probably drill holes all over the place and put zip ties through it everywhere, but my harness is going to be a little bit different. But first I have to peel this banana. Peeling a harness is gross, sticky, gooey, time-consuming. But I'm so glad to have every last thing that I need to finally get started doing this job. Oh, for the love of... Are you kidding me? Seriously? There went the overheads. I cannot shoot the rest of this video with this light source. This is horrible. This wasn't the kind of wiring I wanted to have to do right now, but you'll thank me later. These 8-foot fluorescent fixtures are extremely hard to find, and would you quit it with the subtitles already? This might as well happen. now we can finally see the carnage that we're starting out with. Let's start with that biggest connector that has that silly bullet connector hanging off of it. Most of the ECU pins that failed are on this connector. There's multiple splices and soldered joints close to these terminations, and that's a bad, brittle thing. The pins are loose in the connector, the locking clip is broken, so once you clip it in, it's awfully difficult to remove. And you can see the gouge marks from everyone having to use pliers to remove it. The 18-pin connector looks okay, but all the pins are loose. The old wires have been wrenched back and forth due to the fact that the firewall bulkhead and ECUs are in a completely different place between a Hyundai Elantra and a 90 Plymouth Laser. It's a terrible fit, and all you can do about that is make your own harness. There's an equal amount of things wrong with each of these connectors. This little one's just got all that damage spread out over fewer wires. It's all bad. I hate all of this. Let's go find other things to hate on. I tagged every connector that I unplugged when I removed the harness. The ones that I didn't have to disconnect from anything aren't marked. Let's start on this end, this connector. Doesn't look familiar to me at all. These are tagged. We know what those are, but this one's not, and it's round. I don't know what this is, if this is Hyundai or what's going on. Oh, alright, I guess it's nothing then. How about that other one?
Really?
Weight reduction. Then there's stuff like this. Stuff that's not connected on one end but spliced into the middle of the harness. No go.
What?
This harness was cut up by its original owner, and I removed it from the donor car back in 2005. It was used as spare parts for a different project once, and then handed off to Jamie for repair, who also grafted it to the Elantra body harness. And then I hacked and chopped a bunch of other unused connectors off of it a couple of years back. Imagine my amusement when I discover all the wires that I carefully terminated, insulated, and wrapped last time. They're not connected to anything on the other side of the firewall either. I could have just pulled them out. They never needed to be here.
What the heck is this? There's my noise filter. What's that going to? A cut 3mm wire. It goes to
Unused.
a relay socket.
And the only wire connecting the empty relay terminal to the rest of the harness is a what?
It's just a ground.
Yes, indeed.
That's completely useless. And what about this?
It's also not in the wiring diagram, but it's supposed to be wired to the coil primary to eliminate RF interference in the engine harness and radio. Explains the dirty data logs entirely right there. Once I was done assessing all the damage, I filled out notes for every ECU pin into my spreadsheet. I measured all the lengths of every last leg of the circuits because it fit once before, so that should be a good starting point. But your arms aren't long enough to measure everything, so at some stage you need to call a good friend to come over and hold the dumb end of your tape measure because you have to pull the wires tight to get an accurate measurement. With all my measurements and notes taken, I now have reason to start handling connectors and cutting new wires off the spools. I'm using my wire striper just to keep myself organized for now. I'm not going to terminate any of the ECU connector pins before I've got the rest of the connections made, so the wire colors will be important later. My idea for fixing the fit of the harness first involves making all of my other connections, then installing the harness in the car and training the wires into their positions. Once I'm happy with it, I'll mark the ECU sides of the wires where they need to be cut to fit properly and bring it back in to finish it on the workbench. It's a little bit extra work to handle each wire twice like this, but the payoff in the end will be a better fit. The first batch of wires I'm starting with are the ones that go to the resistor pack on the firewall. They're all black 0.85mm or 18 gauge, and they're the only ones that use this diameter wire on the entire harness, so I figured let's get that over with first. I hung them all on my garage door track while they dried. There are two different types of waterproof grommets that could be used with these WeatherPack connectors. Some are squishy silicone, and the brown ones in this kit are the harder, more plasticky kind of material. Note that the hard ones are actually oval shaped, not round like the squishy ones. Look inside the backs of each of the connectors you're using before you put these on the wire to verify the shape of the holes are right. The oval grommets go in the oval shaped holes. It's as simple as that. Cut the appropriate weather pack pin off the die cut strip for whatever connector you're terminating, install the grommet over the shielding on the wire facing the proper direction, and place the wire between the small crimp tabs on the connector pin. Using these proper crimpers made for the connector, crimp the inner tabs firmly to crush the wire into place. I like to also use the adjacent slot to crush the same pattern on the back of the crimp as well, while firmly pulling on the wire. If I can't pull the wire out, then I've got a good crimp. Next, move the grommet into place against the larger outside crimp tabs and crush it firmly around the grommet using the proper slot on the crimpers. Now you have a pin that's prepared for installation into the connector. If you try to install the pin backwards into the connector, it either won't fully seat or it won't fit. When you get it right, it'll click firmly into place. Now I just need to terminate both ends of the other 3 fuel injector resistor wires and install the injector and resistor connectors. The injectors use the oval grommets and the resistor pack uses a squishy round one, so I might as well strip and prepare both ends of each wire first. Next I clip off the pins and terminate each end. The easiest way to do this is to place the pin inside the crimpers and hold it while you insert the wire in with your other hand. Once you've got it lined up, squish hard, it's crimped. The only thing you really need to look out for is how sometimes a protruding tab of metal from the die cutting process or from a loose or bad crimp prevents that pin from being able to fit through the hole in the connector. Most of the time you can feel it if that happens, but it's hard to see while you're installing it because the grommet gets in the way. Also, sometimes crimping the grommet bends the connector lengthwise, making it interfere with the hole. It only takes patience to become a pro. Because I'm making a new harness, I'm lucky enough to have another one right next to me to compare my connections to and ensure that I'm installing each wire into the proper pins. I could have used the wiring diagrams markings and all of my notes to determine all this, but this saves me a whole lot of time. I'm just probing for resistance to check continuity across terminal pins and copying their locations. I'm not relying on wire colors because all the splices in this old harness is just a mess. The old injector plugs were spliced on from a completely different car and none of the colors match. I don't think that's an unusual thing to find on a 30-year-old engine harness. It's just something that you need to look out for when you're working on your own. A job like this can seem overwhelming. It looks like a complete disaster. The power of observation is really your best friend. Just focus on doing a good job, one connector, one wire, one pin at a time. Be methodical, and you'll be surprised how fast you make progress knocking it all out. I'm running my power and grounds last. Those are going to be easy. There are parts of this old harness that I'll have to graft onto the new harness because I just can't find replacements for them. Good luck finding a 92 Elantra body connector. Now I need 4 legs for the injector pulse going back to the ECU. It says I need yellow and light green wire. My notes show these are all different lengths, and this is why you take notes. To save additional effort, I'm also marking out an inch ruler on my table. There's my yellow wires. Now to ensure to put the right length stripes on the right length wires. One gets black and this one gets blue. Don't worry, you don't need to document stripe lengths. Sadly, I don't have any light green wire. All I've got is green. Looks like it's going to be green then. And only one of these gets a white stripe. Whatevs, I got this. My next order of business is to terminate the last 4 injector pins, pair the right length and colored wires with their proper mates, and then install each pin. Once accomplished, I bundled up all 4 of the ECU ends together and branched out the resistor pack leg. We'll return to powering the resistor later. The Mpi circuit is the power source for your injectors, but at 4.5 volts instead of battery voltage. That's what the resistor's for. The ECU fires the injectors by pulling that current to ground. Next we work on fire. This is the ignition transistor connector. Pin 2 and pin 7 go straight to the ECU, so I'm going to do those first. Both wires are yellow and they're the same length. One has a red stripe on it. If you've got the old harness, go back and trace the entire length of each wire that you're replacing through the old harness. Diagrams are nice and all, and spreadsheets are useful, but look at what you're replacing and where it goes. See if and where it branches. Find your junctions. Right now I'm solely focusing on the things that connect directly to the ECU without any splices or junctions. The other pins on the transistor route through Mpi power, the coil, and the Tach filter that's on my particular car. Well, we're not going to worry about those right now. I'm just addressing the trigger wires. Now for air circuits. The idle speed controller is another pin hog. It has 4 coils in it, so there's 4 pin connections at the ECU. Lucky for me, they're all solid colors and the same lengths this time. My ISC worked beautifully before all this started, so I'm just copying the same layout of the old ISC connector. Before I get in too deep, I'm going to start marking the new connectors as I go. The more of them you complete, the less unique they look. There are several places where the same connector does a different thing, and it'll be helpful to recognize them with a glance once we get to the test fitting stage. Next up is the top dead center and cam angle sensors. These aren't air, fuel, or fire circuits. These are for timing the events to make them burn correctly. A solid black and a solid white wire. That wire folding thing that I do, it isn't necessary, but I find it helpful. Should any crimp ever come loose, pulling the wire tight will actually tighten the crimp, whereas a wire without the bend in it will just pull right out of the pin. Also, my logic to doing it this way is that it makes more contact surface area with the copper, putting twice as much copper in there for it to grip. The factory does not do this. Almost nobody takes the time to do this, and you don't have to. A good crimp should hold just fine forever either way. If the wire were thicker, I wouldn't. Here's the close-up of the Grommet crimper in action. Those crimp pliers are expensive, but dang, they do some pretty work. Both cam and crankshaft angle signals on a 1994 G63 come from the cam angle sensor that dangles from the end of the cylinder head. It's responsible for telling the ECU which injector and which spark plugs fire and when. The black wire is the crank signal, the white wire is the cam signal. Both of these wires route directly to the ECU. The other 2 pins on that connector are a power and ground, and I'm getting repetitive, but we'll come back to those. Next up, we've got the throttle position sensor. On a 90, this is a busy connector. The wires I need to run to it are green and green. On a 90, the throttle switch is added along with the throttle position sensor so that connecting one connects both. The throttle switch gets its own intermediary harness from the throttle position sensor. Also, it uses a male connector, and that's why I'm installing pins instead of sockets here. This is the only one we've used, and it's the only male connector in this kit. It's a fact that over 93% of all of Jafro's harness connectors are female. My audience is probably in the 6% range according to statistics, but hey, you people know I'm trying. Now for the coil wires. Being that I have a 90 and the electrical diagram I have is from a 91, it's all completely wrong. My coil connector is square and it includes the white wire for the Tach Signal. After the 90, it's separate. That then branches off to a Tach filter connector, and it gets even weirder the closer it gets to the ECU, but let's not get ahead of ourselves. We're not there yet. A 4G63 uses a waste spark ignition system where there's 2 coils for 4 cylinders. That means that each cylinder fires basically at the top of every stroke. There's only a fuel mixture there for half the time anyway, so it's like a fart in a spacesuit, only the ECU ever knows it did it. DSMs use beefy coils that can easily handle the double duty of firing twice as often as they need to, so there's only 2 trigger wires to run and fire all 4 cylinders. Well, sort of. These don't connect to the ECU at all. They actually connect to the power transistor, which is taking its directions from the ECU. So the trigger wires for these coils go to pin 1 and pin 8 of the power transistor connector. Pin 1 gets the yellow and black, and pin 8 gets the yellow and green. The reason I mention these wires is because if you install some funky cam angle sensor setup that puts your spark 180 degrees out of phase from where it should be, instead of shuffling your spark plug wires around, pull the transistor connector and swap pins 1 and 8 instead. There's a black wire that goes to ground from the transistor, and this white wire is the Tach Signal, which we'll leave dangling for now. That's the one on a 90 harness that gets really weird the closer it gets to the ECU. You'll see. My boost control solenoid uses an old Honda connector from Foofy. I always want to keep that part of this car, and the sensor is already wired with the matching plug, so I'm taking it with me. I put little tags of red electrical tape on the connectors that I had pinned signal wires for, just to remind myself which ones had already been completed. Here's one. Remember my old MAF harness from the last time we were in here? Surprisingly as rough and spliced up as these 6 wires looked, it was fine. These soldered splices are as hard as a rock though. It was wrapped in this sticky cloth-like insulation. Yeah, well, I needed a mass airflow connector back then, but I don't need it now. Power and ground aside, there are only 2 wires on this harness needed for speed density, and that let me delete most of the circuit. I'm still going to match the factory color schema on my wire selection though. Instead of having a mass airflow connector, I'm just wiring directly to separate intake air temperature and map sensors in order to get the speed densities utilizing these GM connectors. So naturally I'm using the Delphi Crimpers here. Never mind that one of these is the wrong plug. Forget that little detail. Let me make my mistakes. I'll run their power and ground wires later after their fit and locations are all sorted out. So I only need to terminate 1 pin on each of these. Did one of them slightly wrong, but still very effectively, and that wraps up the air circuits. Last thing to sort out before we do the test fit is the coolant temperature sensor. I just had a couple of wires haphazardly loomed together with a couple of female spade connectors. I mean, they're 30 years old. Whose don't look like this, right? Needs 1 yellow wire with a green stripe and 1 green wire with a black stripe. I'm all out of green, so I'm going to use this black with a green stripe on it instead. It should stand out like a sore thumb and be easy to trace. None of the other wires with the secondary colors pre-striped on them in this kit matched up with the DSM harness exactly, except for one of the injector connections to the resistor, and this backwards little combo here. With my fancy wire striper though, I don't really need anything but solid colored wires anymore, and apparently you can never have too much green. The Sheridan engineering kit came with a factory coolant temperature sensor connector. That's something I haven't seen on any of my 1G cars at all, ever. This is completely new to me. I just thought they all had a pair of loose female spade connectors, and you're supposed to just guess which wire went where. I thought that coolant sensor plugs were just for 2Gs. I'm happy to admit where I'm wrong though. So this is where we came from. I still have a few things that I need off this harness, namely the body connector, but I've done my best to leave as much of this thing as possible intact up until this point. Previously, the harness was way too long for this car, causing problems with G-forces, chafing, and stress on all the components that it connects to. Simply securing it never proved to help either. It seemed to help for a little while, but then I was back to the same stupid problems with intermittent shorts and loose ECU pins. I've been chasing my tail fixing this thing. Once a new harness is installed, the circuits will all be trimmed to length at the ECU, and that'll mark the distances to their components. That will expose how much wire to use to run all of my power and ground circuits, most of which are connected to the Mpi Relay, which we haven't even touched yet. So let's get to it then. I put a piece of wire loom around the bundle earlier, which makes it easier to shove everything through the hole in the firewall and to route it to where it needs to go. It might have been easier on the engine bay side to install all the connectors one at a time and pass the stuff through, except that bundling it all up on the other side and routing it to its home would have been exceedingly distressing. And here's what it looks like from inside the car. The hole is obviously where you see daylight coming through, and I need to route the harness up and over the steering assembly and the pedals to clear everything and along the bottom of the dash and down to where the ECU is. Because the pass-through hole is on the driver's side of the Elantra rather than the passenger side of the Plymouth Laser that it came from, the distances to every single sensor in the engine bay have changed. All of this car's issues were greatly complicated by this before. It's why the speed bumps and temperature changes could make permanent adjustments to my tune. All of that will end when the harness just fits correctly. So after sitting around and pulling on my cable for a couple of hours, I ended up with this. I started on the far ends of the branches and worked my way back to this hole, bundling and taping as I went. You can see all the branches of the harness. You can see where the resistor wires return back into the loom, where the branch occurs between the fuel and ignition stuff, how the fresh and completed fuel injector connections all fit perfectly, and how I put the wrong map sensor plug on it and it's just laying there laughing at me. On the other side, you can see just how much of this extra and unnecessary wire there is. Think. This is the excess only from the signal wire. There's no power and grounds here, and it doesn't have a boost control solenoid, body harness, or a knock sensor on it either. So basically it's this times at least 3, about 4 or 5 feet of extra harness. These are all Elantra problems. I thank all of you who are still watching. I said before that there was no knock sensor circuit. Well, there is now. I don't see the purpose of trying to find this wire when there's nothing wrong with the original factory one. It's only bad where it's spliced into the connector, so I cut just above the splice, and yoink! Knock sensor circuit. I just need to plug it in and snake this thing through the rest of the way to the ECU for fitment. I did the same thing with the foofy cable on my Ingersoll Rand 3-point boost control solenoid. Why repeat this work for what I've already done before? But after all those things were sorted out, I trained the wires into shape and taped them up with the rest of the bundle. The purpose of this test fit is to see where I need to cut the harness to install the ECU connectors. Obviously, I was very safe starting out with the factory wire lengths. Not a single one of these wires are too short. And it's a good thing that I remembered to leave an extra inch in case I screwed up, because I ultimately did. It's too long of a story to be worth all the editing. Cliff Notes version is it cost me another 50 bucks, but it's alright, I got this. But now that it's cut, I can remove it and take it back in on the workbench for the finishing work. The resistor pack connector was way too long. I guess this is where some of the waste begins on this job. I terminated these connectors and they're not reusable, so they gotta go. Normally your connector should have this green plastic thing shielding the pins, and I don't yet, but once you pop that thing off, you're not done. You still have to pop the release tab that's holding onto the pin while pulling it out. Look, that was too quick. It takes 3 hands, but the tab is a lever that's on the top of the pin, and it's just got a tooth that won't let you pull the pin out from the back unless you release it first. Sometimes after you unlock it, it helps to give it a little poke. There you have it. There's all the little locky levery things that are in there. There's much better videos about this than mine. So with the resistor cut off and depinned, before I put that back on there, I want to run some heat shrink tubing all down the sensor leads for some added shielding and protection on every endpoint, and to give the rest of my sheathing something to grab onto. I'm not going to get fancy here. I'm actually going to stay with convoluted tubing for my sheathing because I really like its low budget appearance on this car. I think it looks right at home. Plus, I've got bags of it. It didn't matter that I had to peel off all the tape because the wires are all now the lengths that they needed to be. But after all the heat shrink tubing was in place, I slid an excessively long piece of Raychem 25 over the trunk. I'll cut it later. This is for added protection where it goes through the firewall, and it'll help me train the interior wires permanently into place when I'm finished. I tagged the ECU side to help me pin out the connections more easily, and now it's time for the ECU connector termination. These clips are really simple. They're not too different from the others except that they have 2 guide tabs that you're not supposed to crimp. I'll show you. First, I'm going to get to strip these 23 wires and do my wire prep thing though. You lay the wire in there just like you did with the weather pack connectors, and then you crimp the inner and outer tabs only. The ones in the middle sticking up are the guide tabs. The outer tabs grip the wire insulation to prevent the inner tabs from being disturbed, and it also prevents the shielding from being pulled away from the connector in the event that the wires get stretched. It's a nice solid connection. Now to do that with the other 22 wires. I started with the 18-pin connector because it's where all the fuel and fire circuits live. It has the most pins that are ready to go, and next I figured out the 24-pin connector. When you install the pins, the number order is always looking into the front of the male connectors. When you're installing pins into a female connector, you always look into the rear of the connector. Pin numbers go left to right, top to bottom, with the clip tab facing up. The drawing always notates male connectors unless the connector is drawn with an extra box around it. Then it's a female connector. If you want a closer look at this, there's the little yellow bumps at the top of every slot that the guide tabs go around. I found these replacement connectors to be extremely snug, often requiring slightly squishing them with a pair of pliers so that they can fit. Even after the squish, I still need to use the pin extractor tool to mash the pin and jam it all the way down into the hole to lock it in place. I'm glad that this is such an extremely tight squeeze though. The connectors that I'm replacing allow these pins to loosely rattle around inside the holes, and it turned this into a huge problem for me because occasionally pins would even open short. The only connector where the pins fit without the modification of squishing them is the 10-pin connector, and the only wire on the little connector that I've got a pin ready for is the boost control solenoid trigger. And that wraps up all the beef with the connector locations on the engine harness except for the Mpi Relay and the body connector. I'm simply going to harvest and transfer the body wiring over to the new harness. This process, of course, is specific to my Elantra, and nobody here is going to learn anything from this part, not even me. It worked before, so I just transferred one wire at a time to the new ECU connector wherever something was directly connected. And 8 wires were. These are the connections for things like the check engine light, the dashboard coolant temperature gauge, the vehicle speed sensor signal, AC compressor clutch relay, power steering pump pressure switch, and the Tach Signal. None of these body connections will work the same on your car as they do on mine. They just need to be sorted out on whatever thing that you manage to put a 4G63 in. And finally, we've got that weird, confounding white wire from the coil that I've been talking so much about. That's the Tach Signal. Just like the knock sensor, it uses this special wire-stranded RF shielded cable. I'm just going to house this and transfer the Tach Signal wire over from the old harness as well. It was the twice repaired ECU pin side that was giving me so much grief, and of course I'm cutting that off and replacing that. It's extremely difficult to match this wire. I'm sure it can be done, but 1 inch past my ECU connector, nothing else is cut and it's all in really good shape. It gets grounded on both ends, and the wire stranded RF shielding also gets crimped to a ground wire and pinned into the ECU. On my old harness, all of this was broken while the unused oxygen sensor circuit behaved as one big long radio frequency interference antenna. This, in addition to not having a noise filter, was the cause of all of my dirty airflow signal and false knock readings that retarded my timing and threw all the performance right out the window. Because this is the Tach Signal, one leg of this circuit is already terminated to the body connector, and we'll sort out the rest of it once I've got the Mpi Relay's power and grounds figured out. But I have to pull that body connector pin out if I want to fit this Tach Signal spaghetti through the trunk of this wiring harness. This cheap 3-piece WeatherPack connector toolkit has been the best impulse buy I've ever made, and I did it back in the 90s. Also, I planned ahead for this moment. I ran an extra wire for the coolant circuit earlier that's way longer than it needs to be. It isn't connected to anything yet, but using it, along with this extra piece of pink wire, I looped both ends and taped them to make a strong connection, and I'm using it to shuttle and pass wires up and down the trunk. On the first pass, I'm running the gauge cluster coolant temperature sensor wire up the loom from my body harness, and onto the return pass, I'm going to pull the Tach Signal spaghetti right on back through. Once everything's freed up, I pop the Tach Signal back into place into the body harness connector, and I'll trim up and terminate the rest of the ECU stuff later on the Tach Signal wires. There's a whole lot more involved with doing that. I'm just trying to stuff this piece of Raychem as full as I can with the rest of all the other things that it's going to need first. I need a green wire with a red stripe on it for the 5-volt power feed that goes to the barometric pressure circuit. I'm all out of green wire, so I'm just going to use this mostly unused red wire and put a really fat green stripe on it instead. After it dried, I shuttled it through the harness to where the map sensor lives. Next, I cut the wrong map sensor plug off the barometric signal wire, installed the heat shrink tubing that I forgot to install earlier, and then repinned the barometric wire and installed it into the center map sensor connector where it belongs. Now, with all my boneheaded mistakes corrected, I now know how long to make the 5-volt power circuit. It's as long as that right there. So I just grab the extra red and green wire that we didn't use and make a shorter leg to splice into that circuit. That's 2 out of 3 map sensor pins. To get the lengths right for the throttle position sensor leg, I had to pull the wire back through the harness where everything will live. Next, I prepared the pin for the throttle position sensor and installed it where it belongs. I made my test fit, made my cut, stripped both wires, barrel crimped them together, solder sealed, and then shrink tubed, insulating them. I know that seems redundant putting 2 different things of shrink tubing over it. I like to add the second piece over the solder seal connector to protect it because it's smoother and less grippy than the soft rubbery insulation on the solder seal connector. I'll be feeding wires all up and down this trunk, and I don't want to pull the insulation off of my work while I'm doing it. And if I do, I don't care if it's the shrink tubing. This connection goes to the sensor's ground, not the chassis ground. These are for the sensors that ground themselves to the ECU. It incorporates the map sensor, which is formerly the MAF sensor, the intake air temperature circuit, the ECU's engine coolant temperature circuit, the EGR temperature sensor, and the throttle position sensor. These are your 5-volt circuit's grounds. Do not connect these to chassis ground. Of course, I have no mass airflow sensor and no EGR temperature sensor, so there's 2 less wires I need to connect, but there will still be splices. I started on the outermost junction and worked my way down the harness so that I could crimp, solder seal, and heat shrink every junction. Thanks to memory cards and battery issues, I ended up with this once I was finished. With the engine bay side sorted, time to pull it through and work on the ECU side. Not only does the ground circuit connect to a half-dozen components inside the engine bay, it also forks and connects to 2 different pins on the ECU. For all of my crimps, just like the factory does, I'm using open barrel crimps. It's just a little copper tab that crushes into a specific shape if you've got the right crimping pliers. I bought what I thought were the right ones, but they sucked. They kept breaking the crimps. The Hosan crimpers wound up doing a better job, and if I started large and worked my way down, it rolled the barrel crimps into the perfect shape. You might remember I had a problem with these things on the old harness, and that's why every crimp I make is getting a solder seal connector in addition to a tight crimp. And there you have it. The 5-volt sensor's ground connects to pins 17 and 24 of the big connector. Some of these connectors are really starting to fill up, man. Like I said earlier, be meticulous, trace your old harness, take notes, do 1 circuit at a time, and you'll get through it. Now we're going to get into some of the fun stuff. 12 volt power. This uses 1.25 millimeter wire, which balances out to roughly 16 gauge in Cajun country, and it's distributed by 2 wires that run the length of the harness that are tethered together. The power circuits on these harnesses look like a mess from the factory, and they are, but there's not really a very tidy way to do it. I'll try though. In addition to the 2 ECU pins and connecting to each other, they also connect to the Mpi Relay twice, the idle speed controller twice, the cam angle sensor, the mass airflow sensor, the O2 sensor, and the resistor pack. An additional leg will also be added for my wideband sensor as well. Of course, I don't have a narrowband O2 or a mass airflow sensor anymore, so my circuit's not going to look anything like the factory one. I made the first run with one of the wires to the idle speed controller, and then I fashioned 2 power legs for the cam angle sensor and the resistor pack. Both of those got spliced in with the same methods, but I ran into one unfortunate caveat. I didn't get the resistor pack wired to the right length on the first test fit, and I peeled all the tape and cut the zip ties, so I don't know where to attach this resistor pack wire to. It's nice to have all this buttoned up on the connector though. Man, I can't tell you how satisfying installing that thing feels. This green thing means the connector's finished. But yeah, I have to test fit this thing again in order to figure out where all this lines up, just so that I can terminate that one power wire. Quick, to the Jafromobile! Hopefully this will be the last time this is ever difficult. Wires and connectors all snagging on things. I'm going to take a minute, or in your case a second, to attach the factory intake wiring shroud back onto the harness since all these connectors are done. I just need 1 coil wire, and I can still do that. That means that things in here are starting to really get official. And with the harness installed where it's going to go, now I can make my mark where I need to splice it and bring it all back inside again on the workbench. The resistor power. It goes right there. That's the one. Barrel crimp it. Solder seal. Shrink tube. You know the drill. Now with that leg complete, I'm going to install 1 more pair of shrink tubes for a future install, and then splice these 2 circuits together. I terminated the other wire on the cam angle sensor side to keep the lengths even, and then crimping both legs of the circuit together rather than running a spliced wire between them. It accomplishes the exact same goal. The circuits are joined, and there's nothing to snag onto while building out the rest of the harness. That's the big one. Like right now, I have to pull this thing through the sheathing. This thing's getting full, man. Maybe I should have bought 1 inch instead of 3/4 inch. Seems to work well so far. Both of the ECU side legs of this 12 volt circuit also have an additional 16 gauge wire extending off to the Mpi relay. I spliced those further up into the harness, away from the ECU pins, so as not to stress the junctions where those circuits break off. Additionally, I added a 20 gauge power wire into this crimp for my wideband oxygen sensor. We'll do that last. Pro tip, you kind of want these things to cool off before pulling it inside an unshrunk piece of shrink tubing. Yoink! I pulled on the cam angle sensor connector that these wires are attached to straighten things out, and then reconnected the pins to ECU number 102 and 107 on the small connector. I'll worry about the Mpi Relay connector legs in just a minute. I still have 1 more circuit to complete before we can start on the Mpi Relay. I guess I don't need all these tags on these connections anymore. We know what they are, and they fit where they're supposed to go. She's looking good, too. I underestimated the shrink tubing length here, so I decided to add another piece just for the coil. And with the shrink tubing in place, now I need the coil wire. The last coil wire. I'm using 14 gauge or 2mm TXL wire for this. It's easy enough to feed this wire back through and do that, but it also branches twice once it gets to the other end. It gets a 2mm leg to the body harness, and a 1.25mm leg to pin 110 on the small ECU connector. To get my wire lengths correct, I start by terminating the last empty coil connector. With this wire, all of the engine bay connectors are now full, save for a few grounds, but most of those are even already attached. And that pretty much wraps that one up. We'll save the rest of the plastic locking things for an upcoming ASMR session. Here on the other end, it connects to a body connector pin, and I'm going to make all the rest of the wires for the Mpi Relay real quick. While I was at it, I made the ECU's ignition switch input wire. It sort of needs this wire. Kind of important. Anywho, I suppose it's time to finally bust out the Mpi Relay. I just can't put it off anymore. I confess that it took me a minute to get the hang of these crimp terminals.
saved it.
But did you see that? I just got so lucky. I don't have spares. Well, one spare really because one pin isn't used, but I don't want it to be for that. Mpi pin 3. That was the coil wire. Now for the other two 12-volt sensor wires that connect to pins 4 and 5 that have just been sitting here patiently waiting for me to get back to them. I got both of them terminated pretty quickly and without any real fuss this time. Got both plugged into the Mpi Relay connector and it's already 33 1/3% done. Time to finish up that coil wire though. I took the wire back out of the connector to make the next connections so that I could avoid accidentally shrinking my harness. Things are tight here now that the sheathing is full, and now it's crimp time. I added the ECU pin and gave it all a good smashing, and then demonstrate proper shrink tubing etiquette. Did you see that? Wow. Nothing's more frustrating than finishing the junction and discovering that your heat shrink tubing is on the wrong side of the junction. It's a dance and it takes practice. Just think it through before you crimp. If you're good at puzzles, then you got this. Next up, we've got some more problems here. There's a bare exposed crimp on the factory wire for this circuit. And this is a constant hot because it's the battery backup wire. It goes to MPI 10 and ECU pin number 103. If there's ever some battery draining device that you wanted to wire in to suck the life out of your car while it's parked, this would be a good wire to install that on. With that bare crimp terminal problem solved and an extension to Mpi Relay pin number 10 terminated and installed, it's time for more. I need more. Next up, we have the starter relay wire. It's a 2mm black and yellow wire that connects to the body connector as well as the Mpi relay and also pin number 108 on the ECU. It doesn't connect to anything in the engine bay though, so I just made both lengths of wire to reach the Mpi relay, and rather than splicing them in the middle anywhere, I just pinned both of them to the Mpi relay pin 9 to keep all the shielding intact. Moving on over to pin 8 on the Mpi relay. I really don't know what this circuit is. Hey, I don't know everything. Maybe some sort of trigger from the relay, I don't know. What I do know is the original one had a piece of 125mm wire with a crimped junction going to two 0.5mm wires that connected to pins 63 and 66 on the ECU connectors. They were both black and blue wires, so rather than make a junction that I have to shield, I just pinned two black and blue 20 gauge wires to Mpi 8, just like the last one. Because what's the difference? Suddenly the Mpi relay is 66 2/3 finished, and that takes care of two more ECU pins too. Now I've got this red and white 0.5mm wire and I have no idea what it does either. Pin 56 on the ECU harness connects to Mpi Relay 7. Nice, an easy one. If I were smart and followed my own advice, I'd read the diagram and see that it indicates that the last two pins are both Mpi Relay coil triggers. One is on the ignition switch through a series of safety mechanisms, and the other one goes to the ignition coil. I don't really care though, I just want to be finished, and I looked at this to see where it went on the old harness before I did the voiceover. Alright, only one left to go. We've got the fuel circuit that runs to the body harness connector with a 2mm black and green wire. It also goes to ECU 13 with a 0.5mm black and white wire and another black and white 1.25mm wire to the fuel pump test connector. I'm going to start by terminating the Mpi relay and then attaching the fuel pump test connector from the old harness. This is another one of those why reinvent the wheel situations. Unfortunately, I can't do all four legs of this circuit with one crimp because the dang body harness wire is too short. Next, I made a 2mm extension from the body harness connector to the fuel pump circuit. I got my measurement marked, stripped, and prepared a barrel crimp, and then I added the fuel pump voltage monitor input wire to the ECU circuit. With that insulated and finished, now there's only one Mpi relay pin left, and that's where the mother of all ground circuits begins. Right now I have two signal pins left for the ECU to complete. One is this fuel pump monitor input, which I'm finishing up right now. The other is the Tach Signal wire. I saved the Tach for last because just like the knock sensor wire, the Tach sensor signal's radio frequency interference shielding ground is integrated together with that one big mother of all ground circuits. And none of these circuits I've made are even circuits at all until they're properly grounded to the body and the Mpi relay, because nothing will even get powered. My ground circuit is going to be quite a bit different than the factory's. Of course, I brought a few of its legs along with me, but let's take a closer look at what the factory did and make some sense of all that before we start. There's a ground lug that's bolted into the car's interior near the ECU.
It's a nice big 2mm wire coming from it, and I've already peeled the tape off the first factory crimp, exposing a spider web of other 1.25mm grounds. You can see one of them connects to the ECU pin 106, and there's supposed to be another one to 101, but it was broken off. The cut wire here used to go to the radio frequency ground circuits. But if you travel back up the big ground wire to yet another splice, there's the big 2mm leg that connects to MPI 6. You'll see next to the big wire that there's another ground that runs parallel to it. It's a thinner 1.25mm wire, and that one connects directly to the cam angle sensor. There's a big ground lug to the chassis up here in the engine bay side as well. It's on the opposite end of the big ground wire. There's a solenoid wire dangling for something that I don't have or need anymore. That's going to go away too. But the big wire basically goes from lug to lug, and it forks to the Mpi Relay. All but one of the other ground wires are crimped to the big 2mm wire, and even the ones that aren't are still grounded to the lugs. There's also a ground wire that goes from the ignition power transistor to the engine bay ground lug. You can see that I've already made provisions for the transistor wire, as well as the Tach Signal RF ground circuit. I just have to attach that to the knock sensor RF ground to do this. And I don't really feel like doing that right now. I think there's plenty of other things that I can keep myself distracted with, like this stupid relay with diode. That's what Hyundai calls it. I really wish they were more specific about what this is or what it does. I spent an entire day figuring out the way the Hyundai service manual does things and how it works, all to no avail. I didn't have a good time. I figured it out, except none of the information pertaining to this Elantra's body connector is either accurate or specific. None of it. Even they admit that their cryptic numerology is peculiar to the connectors. First off, this is the body harness that came with this car. This is the 21-pin body connector I actually have, but the manual identifies it as the M38 Tach connector that lives under my driver's seat. So when I go to the location for the right connector to see what's listed, it shows this 22-pin connector instead of a 21-pin connector. The factory service manual completely misidentifies this with a different connector. Some of those pins have the correct equipment connected, but on completely different pins, and the wire colors don't even match. The worst troll in my case is that each connector is spread out over 149 pages of one gigantic schematic diagram, so first you have to scan every page and schematic to find the peculiar connector code, and if you're lucky you'll get more than 2 pins worth of connector on one page of the diagram. It's so absurd that you may have to find one connector on as many as 10 different pages to get all the pins. I've scrolled through this so many times now. Since I can't tell if I can delete it, to clean this up I just extended the wires to that pointless looking 2-wire relay with diode that's bolted to my firewall. The AC compressor plug wasn't so lucky. The RF shielding on one of the Tach wires wasn't connected to anything. I said one of the Tach wires. Yes, this car has 2 Tach circuits. One actually goes to the Tach from the engine bay through the body harness, and the other one goes to the ECU. It would be helpful to have both of these grounded, don't you think? And now they are. I spliced together the Tach wire that extends from the coil to the Tach filter connector to complete the engine side of the confounding circuit, and was thrilled that I cut it to exactly the precise length that it needed to be, by accident. Cool. I still needed to crimp the boost control solenoid to the 12-volt power circuit, and this is why I pre-installed extra shrink tubing here before I made all the other crimps on this circuit. Just like with the resistor pack, I needed to test fit this to see where it goes. Custom tailored fit for the car. Cool. Alright, fine, we'll do the grounds now. I cut an arm span's worth of 12-gauge black wire off of the PVC rack. The factory lugs are a good bit closer together than that, but I'll cut this to length later. Next order of business is to get this big wire through the sheath. I broke off the shuttle wire off camera because this Raychem is just so full and the tape wasn't strong enough, so I crimped it this time. I also need the cam angle sensor wire pulled through that runs parallel to it. This is the last ground pin and the very last pin in the engine side of the harness. And now with this last ground pin installed, all the connectors being full is a true statement. I'm going to approach the grounds by attaching wires to every endpoint connection first, and then either splicing them to this 12-gauge wire or to the lugs at either end. I started by crimping both of the RF shielding leads to a piece of 20-gauge wire, and then stealing the shielding off the factory harness to wrap it back up the same way the factory did it. After that, I prepped a 2mm wire for the Mpi Relay and pulled the other end to the trunk of the harness about where I want it crimped on. Next, I made both of the ground pins for the small ECU connector and figured out where they would be attached. And then I procrastinated again by putting a piece of shrink tubing on the Mpi Relay branch. I did a little weaving to put the connectors in the right order and to minimize wire strain at the connector ends so that everything fits where it's supposed to, and then I cut the shielding where I'm making my splices. I loaded up the big wire with all the shrink tubing I'd need to do this, made my crimp for the Mpi Relay, solder sealed, and then shrink tubed it. So now all the remaining grounds will go to the ground lugs and I'll cut them to fit the installation. You know what that means? Right. Time to test fit the harness again. It does keep getting easier and not just repetition causing that. Okay, here we are at the harness side. Just plug in the ECU connectors, the body connector, and the Mpi relay. Next, I plug in all the engine bay connectors where they belong, and with the harness in place, I know where I need to trim the excess for the ground lugs now. And that should do it. On the interior, the ECU ground goes to a bolt underneath the dash. These remaining wires will all be used to attach the harness to several modifications that have been done to the car over the years. Things like the clutch switch for the launch control, the wideband controller, my autometer gauges, the water methanol safety relay. Fans of this project know that these are responsible for most of this car's personality, so it's imperative that I get all those things working the same way they used to. Every wire length is now sorted. There are other ways to ensure all the wire lengths turn out correctly, but to me there's just no better fit that can be achieved than to see where they line up on the car itself. We're in the finishing stretch. All I have to do is the ground lugs, and these are easy enough now that I know where they go. Once again, I bought crimp pliers specifically for these ring terminals, and once again they did a terrible job. So again, the expensive Hosan crimpers saved the day. They're easily the most useful crimpers on this entire job. I applied some adhesive shrink tubing over each one to help everything stay put. Probably could have done that before I put the lugs on, you know. That would have been easier. The factory didn't do this to the lugs, but I like it. It's not for insulation, it's for the glue. Oh, the satisfaction though. I removed all my labels and marked all the connectors so that I can quickly identify them on my bad days. I hit all the connector ends with the heat gun to keep the protective heat shrink tubing in place, and I used my surplus of convoluted tubing to clean up all the branches of the harness. Now for that ASMR session. I think I might have got a little bit ahead of myself. I never actually got around to verifying the only installation location that I could find for the noise filter. It's not in the electrical diagrams. The only information that exists about it anywhere online was posted by 007 Jimmy on DSM Tuners. So I used my completely unmolested Galant's engine harness, and I probed from the noise filter connector to the coil primary power connector. And it most definitely does connect here. 0 ohms. Thanks, Jimmy, you helped all of us. It's just too bad for me that noise filter was laying there and staring at me on the workbench once I finished all my shrink tubing and taping. I wanted to punch myself. I forgot all about it. So even though I hate to do this because it's some of my better work, I had to peel it. I'm more concerned with fixing every last problem that I've complained about since this all began than making a pretty video. I want this. I had to be creative with how I snaked the shrink tubing in there, but I managed to get it completely shielded and protected. I just had to sacrifice the one really nice piece of adhesive shrink tubing that I don't have any more of. As far as everything else goes, it was worth doing twice. It's even better than it was because now it has a noise filter. And it's where it's supposed to be. Being that I never have made an engine harness before, and I know there are some pros out there watching this who can see how apparent that is, I still can't be happier with these results. Most would insist that you not wrap it up until it's test fired in the car, but I just went for it, and we'll see. We'll just place our bets and see how it goes when I turn the key. The entire Elantra engine harness is done, and it's even better than new. But it still doesn't have its interior connection straight for the fart sniffer, its alcohol problem, or its launching mechanism. So what I decided to do, because the engine harness connector kit included an extra 4-pin female connector, that I would cut the throttle position sensor off the old harness and graft it onto the connections from my water methanol kit's boost control safety switch relay, and also for the launch control because I'll have an extra pin left over. For the wideband oxygen sensor, I've got a couple of 6-pin weather pack connectors with matching male and female sides that I can make plug-and-play junctions with. I didn't have a big enough connector to do all the connections on just one terminal, and I had enough of these things that I could have used too, but I wanted a different connector so that they can't be mistaken in the dark under a dashboard. So I started with the power that feeds to the fake boost control solenoid signal part of the circuit. I grafted that into ECO pin 102, which is the 12-volt power, and it's the same source as the actual solenoid downstream. Next, I cut off the pin off the boost control solenoid trigger wire and ran that to another wire on the old TPS connector. Next, I made an oxygen sensor input wire for the wideband controller input. It's yellow on the controller, so I'm going to make it yellow here. The oxygen sensor is pin 104. And next I'm going to use this funky blue wire and terminate ECU pin 3 for the boost gauge circuit. Wait, what? Oh, nothing. I cut and terminated the wire for the ECU's boost control solenoid output pin number 105. Next I made another wire for the clutch. That one plugs in right next to it at 104. And that finishes up the launch control and boost control connector. Now for the wideband connector. These connectors are called 10th moon waterproof connectors. I could say it 100 times and you still couldn't spell it. All I know is that there's 3 matching male and female connectors with pins and grommets for less than 10 bucks. These are actually easier to work with than every single other connector on this entire harness. So it goes power, O2 signal, ground, coolant gauge, boost gauge. Hey! Well, that does it. That's a whole harness built from scratch. I'm not shrinking the Raychem even though it's shrink tubing. It's just for protection. I've abused the living daylights out of it and it's tough stuff just like it is. If it shrinks into shape after I install it, darn. Just putting some finishing touches on it and it's time for the final install. I took the clips off for the test fit process. They can be a pain to fish in and out of there, and I didn't need to lock the connectors down during the test fitting. The transistor is easy enough to do with a pick, but the injectors can be a pain. Best way to preload the clips into the injectors is to take another injector and just partially insert it. Then the clips glide and snap right into place, and you didn't lock your spare injector in there either. Big time saver. Now, for that harness install, I start by shoving all the plugs through the firewall and then plugging in the resistor. Next, I pulled the trunk of the harness through the hole and over the steering and pedal assembly to remove all the slack. Plugged in the knock sensor, routed the boost control solenoid to the other side of the engine bay, pulled the harness under the ground bracket, and plugged in the air temperature sensor, the map sensor, injectors, plugged in the ignition coil and the power transistor, plugged in the relay with diode and the Tach filter, bolted down the noise filter, and I'll come back with a wrench later to finish this up with all the grounds. Attach the ECU coolant temperature sensor and the dash gauge temperature sensor. Boost control solenoid. Plugged in the throttle position sensor, idle speed controller, and cam angle sensors. Man, this is really easy when everything's where it's supposed to be. This extra coolant wire here it's for the autometer gauge, and it's an issue that I'm not covering in this video. And here, back on the inside, things couldn't be any easier. Everything could just plug right in, except that I need to take the time to make sure that everything that's here on the interior can plug right in. I had extra 4-pin connectors in the base harness kit, so I prepped 3 wires for the relay and 1 wire for the clutch switch to plug into it. One goes to the boost control solenoid, one goes to fake power, one goes to the ECU. That way the water methanol safety equipment works properly to limit the car to wastegate pressure in the event of a failure. And this last blue wire for the clutch switch that engages launch control and no lift to shift. 1 plug, 3 features, that was easy enough.
The wideband controller is only 3 wires, but this ordeal is a little bit more complicated. Previously I had problems with it cutting off when the car ran on the turbo timer because the relay that controlled it switched it off when I took the key out. Then I moved the relay trigger over to the fuel pump circuit. That way the wideband works whenever fuel's flowing. But that left me with another problem. I can't run calibration cycles on my wideband sensor without taking my dash apart and jumping wires to switch the relay on. I'm wiring it directly to the ECU, even though the manual says not to. I believe that the circuit can handle it with as much stuff as I've removed from it, but I'm most definitely going to install a fuse inline to protect everything else that's on MPI power. If the fuse blows, the gauge will go dark and the ECU will go into limp mode without an O2 signal. It'll get me home, but it won't run very well. But the other sensors won't short out because the fuse sacrificed itself to save them. Because if for some reason you're ever digging around in your engine bay trying to figure out why your Elantra keeps shorting out and you disturb your wideband cable in a way that it gets eaten by an accessory pulley or your O2 sensor blows fuses, ask me how I know it does that. If you didn't have a fuse on your wideband and you wired it to the ECU, well then the inside of your ECU would look about like the outside of this cable. I was well prepared for this moment. I bought a whole new wideband kit. Yeah, why'd I do that? Well, I showed you the chewed up cable, and instead of just buying that cable, I bought the whole kit because I was afraid that if I bought something and then I had the wrong part that I'd be waiting for shipping and it would delay the video again, and why not just buy the whole kit? So if I had a problem, I could just swap out all the pieces that didn't match. And sure enough, yeah, they had different plugs, so I can't tell you how many O2 sensors I have now with the wrong O2 sensor plug, but I've got spares. Spares to spare. I knew that this was the last thing keeping me from trying to start it, besides installing a battery and putting the charge piping back together. Tighten the noise filter and attach all the ground lugs, attach the positive battery cable, and just like that, we're finally in business.
Ooh, I got a light. The light is on the dash. That's a good thing. There's anticipation, just like as if I had just rebuilt an engine. A little nervous. Power. The car's thinking appropriately. Let's plug in my ECM link cable. Don't need the stereo right now. There's the life. Let's see what ECM link has to say. Does it find an ECU? I started analog. Oh, I see throttle position sensors moving. Oh, this is satisfying. Well, here comes the big test. I guess this is the moment we've all been waiting for. Will it? No. Alright, so there's no Tach Signal.
This job is so big and involves so many things that you begin to question everything.
You figure it out!
I feared that I had fried my ECU somehow in the process because I was sure that I did this right, so I turned to the Galant, which has sat here parked since the last video where you saw me fire her up. All I did was put a battery in it. Starter Bendix sticks a little bit on this one, but she's loyal.
There you go. So the car works. That's proof that the car works. Just want to let you know the
Now to molest the interior panels that have remained unmolested for over a decade, and get to these factory ECU connectors. On the Galant, the ECU's on the passenger side footwell under a beauty cover, because Galants are just elegant like that. Of course, I need the Hyundai's ECU, which is a snap to get to and remove it from its old shipping crate because the engine harness is inside on the workbench again for the 4th time right now. I've mixed feelings about this next startup. I'd be both sad and relieved if it doesn't start the Galant. But one of the things that you should do if you're putting a 1990 ECU into a 1991 and up DSM platform car is swap pins 6 and 14 on the big ECU connector. These are the idle switch and the mass airflow sensor reset pins, and they're reversed on all cars built after 1990. Yes, it is all those other cars who have it backwards, and you can't argue with my logic because the 90s had them in the other order first. They really don't matter much in my case. I mean, the car would still fire if I didn't do this, but with some creative fishing, I can easily set a better example of doing this correctly and leave nothing to question. Now for something this Galant's never had before, ECM link. I'm just monitoring the ECU to see if it behaves any differently inside a different car. There's never even been an ECM link cable plugged into this thing before, but it should work, and it does. Let's see how a GM MAF translator car likes to be plugged into an ECU that's configured to run with speed density.
Alright, so the clutch switch isn't showing. Nope. Maybe. Nope. It's not showing up. Here goes. Me. It's not the ECU, it's me.
Look at the chooch on this one, boys. Injector pulse is wrong and it's drowning in 3-year-old fuel. Sounds amazing though. What isn't there to love about a 4G63 Gallop? Yeah? Well, I want to do that on my other car now. You'll never fix your problem unless you own your own mistakes.
Okay.
I literally probed every wire, swapped cam angle sensors, everything I could try for an entire week before this happened.
Alright, so I've probed this harness pin for pin multiple times. I've had this thing on my workbench in and out of the car 4 different times. And I managed to miss this, but I think I found what the problem is. This doesn't just happen to people in those TV reality car shows. Apparently this really does happen in real life. Sometimes those guys are on like take 30 and they still can't fire it. Well, that was me. I hope that was fun. So we have a skinny black and white wire that go to the cam angle sensor. The way a DSM ECU works, basically the ECU tells the injectors and the spark plugs when to fire, and it does it based off of the camshaft angle sensor. And in here there's a top dead center sensor, and there's also a crankshaft angle position sensor is what the service manual calls it, but that's the cam sensor. There's a black and a white wire on the back of this thing. You see that? The signal wires? According to what the diagram says, those two right there, number 3 and 4, should be a black and a white wire. You can see my diagram says that. On the top, of course, you have a red wire and a black wire. Well, that would be power and ground, right? Yeah, well, after going through this so many times and probing it and actually getting the correct voltage values, the strangest thing I think I've ever tried to troubleshoot. Might have just been my eyes tricking me here this whole time. Let's grab the other harness and take a look at that connector. This is the stuff that if you're going to make your own wiring harness, you got to be prepared to go back through it, through whatever suffering you endure, and figure it out. Somewhere in here there's a cam angle sensor. There it is. And again, you see we have our black and the white wire on the bottom and our black and red wire on top. Doesn't really make different, does it? Black and white on the bottom. Turn it over. Black and red on top, right? Yeah. Well, what I did wrong here, I got the 2 black wires backwards. Leave it to this one connector to have 2 black wires.
My problem was that the black wire was where the black wire was supposed to be.
But the fat black wire is the ground, and that goes on top. And this was 100% me causing this entire problem. With that last test, at least we got to see the Galant run. That ought to do it. I just missed wire gauges. That's it. So now we got the big black wire on top, the little black wire on the bottom. Wrong connector. Just like this one. Big black wire on top. The little black wire on the bottom. Let's get started with the Hyundai burning daylight.
All those times in and out of the car, scrutinizing that connector, probing it over and over and over again, even replacing the cam angle sensor and plugging the ECU into a different car, knowing the whole time that the cam angle sensor wasn't working from the first time that my car didn't start. Mechanical denial is what we call that. It doesn't matter if the cam angle sensor connector is a square connector with solid black wires at opposite corners and looks and probes right if you accidentally get up from down wrong while juggling probes and connectors in both hands. Nope. None of that is an excuse. It's also my mistake. I feel really confident about this now, but I hope I didn't just cross-pollinate and get the Galant pregnant with the Elantra's old gremlins during that ECU swap. That would be totally uncalled for. I put the Galant back together exactly the way she's supposed to be, so she should be good.
Ow! There's the hood there. Should I cut that scene? We've completely run out of daylight. I know you guys have waited a long time for this video, and I'm pretty sure I just fixed the problem, but because you guys had to wait so daggone long for this, I'm going to do the same thing. I'm going to test this tomorrow when there's daylight. I'm going to wait. Yes, I want to know if my entire week and a half of all this troubleshooting was caused by that one little visual swap of wire colors. If I just finished an entire engine harness and that was my only mistake, I feel pretty good. This is something that you're better off getting somebody else to do for you if there's a part available. And if you balk at the price tag, understand that I probably spent twice what you're looking at making this harness and buying all the tools to do it right. So let's see what it does tomorrow.
The things I do for you people. I had to wait till I was getting off work. Yeah, I'm sorry, I'm a minute early. Don't fire me, please. Oops. Hey, it's 5 o'clock now. See, right on time. I can feel the anxiety levels building back up again. The adrenaline levels are rising. It's a little chilly out today, so I'm going to close that. Get all connected, and we're going to find out if the Hyundai fires. I still have some cleanup and some stuff to do in here. I'm going to do some work behind the dashboard. I've already done a lot. I actually completely redid the inside of the center console. Redid all the wiring for my gauges and everything. So we'll see what happens here. Oh, the battery's done. All right. Interesting. Let's fire it up. Does it work? Can it work? Check engine light for 5 seconds. Let's get ECM link connected. Is it talking? It's talking. We got ECM link. Gotta shake it. Oh. You see that? What did you think was gonna happen? Got the cutout open. Switch works. So that was part of my wiring here. The only reason I tested that in the Galant is because I was trying to see if the Galants worked with the ECM link the way it's wired. It had a difference. It's got a different ECU in it, and it didn't. Airflow at idle is way off. See where my ISC is at. Way open, but the engine's cold. Coolant temperature's coming up. Battery's hitting 14.2. It's idling up around 1200 RPMs, which is a little weird. Still cold though. Idle switch isn't connected. switch is connected now. Throttle position sensor's good. 0.63 volts. Wideband's reading stoic. It's talking to everything. Looks like I did a good job. I'm completely happy with this. I have a running Hyundai with a brand new wiring harness that has none of the problems that it had before. I can't be happier with this result. This is a brand new day for this car. I need to get the cutout switch working again. It's not cooperating. Apparently I forgot to wire something up in there. It needs a fuse. I left a fuse out. That's nice. We got voltage. My oil pressure gauge is working again for the first time in a long time. We got 45, 50 psi of oil pressure at idle. Still cold though. Coolant temperature's disconnected at the moment. I told you we're not going to do that in this video. Oh, this is awesome. I'm so glad to have this thing back in service again. Back over again. I guess the only thing I could really do is go back over the tools I used real quick and tell you which ones are useful and which ones weren't. All of that wire right there, none of that was really useful. I did use the 12 gauge on grounds. That worked just fine for ground wire. I had no problems with doing that, making an exception and not using the GXL or TXL. That was not useful. I never even got that out of the case. Didn't need my soldering iron for any of this, so didn't use that stuff. The wire strippers, you know, there's all kinds of creative wire strippers out there. There's some that are useful and some that are not. That's not, this is not. These things right here, I thought I needed those for the solder seal connectors. No, these are for solder and crimp connectors. It turns out that the connectors that I bought here, these solder seal connectors, are just solder only. You don't crimp anything. There's nothing in there to crimp. It's just a piece of solder. So you don't ever actually need to use crimpers with those at all. These were those other ones that I bought that were specifically for these connectors. These were terrible. It's got different sizes on each side, so you don't get a nice big thick anvil to put the connectors in, and they're terrible. Of course you'll need basic tools, stuff to take the car apart, put it back together again, that kind of stuff. I did use the calipers when I was trying to verify my wire diameters, but I didn't use that GoPro, the battery's dead. I don't know if anybody's going to find that useful or not, but I like it. You know, I got the experience of having to duplicate what the factory did, so it's going to make it easier for me to troubleshoot these cars again in the future. Things will be easier for me to recognize and know how Mitsubishi's doing it now. So for me, this was a good exercise. I hope you guys at least were entertained. You'll wind up collecting all kinds of stuff that you'll have spares of. I love having these little crimps. You know, you heard me complain about these things when I was troubleshooting the old harness. You know, they're necessary, but I think that in that kind of an installation, they're not optimal just by themselves. They have a tendency for when wires get stretched or tweaked or torqued on to come loose, and I had that problem all over the Elantra to begin with. So that's why I opt to also use this over the top of it. It's a small controlled amount of solder. I think that's a good thing. I only needed one of these. This was for my wideband, which I wired to the ECU power. I did that even though the manual says not to. Hey, I'm just saying I wanted to be safe doing it wrong. So I bought that, and I got a huge box of fuses. I could have bought one of these things, but you know, I got this with a box of fuses for less than buying one of those things. I used zip ties. I used a razor blade for some of the wire trimming. I used a pick. I used the weather pack pick, which I showed you earlier. These things, you know, I prefer these wire strippers over the others. You know, some people don't like them because they can mar the outside of the wire, but I think it's just the most comfortable, easiest way for my old hands to do it. These things were excellent. The Hosan crimpers are no joke. I got these from Ohm Racing. Ohm Racing was a great source of support for this project. I'm so glad that they carry all this stuff for these old cars. I know there's a lot of companies out there, and you heard me mention all of them. You know, I spread the love around, trying to support as many as I can.
These were extremely useful on the WeatherPack stuff, and they also did a better job on the little rubber grommet things that come in this kit. They also do better on these than the actual Hyundai crimpers do. Even though these can do it, they'll do just fine, but I had better results with this because the handle's bigger. Alright, yeah, you'll need a good set of clippers. I did use the needle nose pliers often. You saw me crushing the pins in order to make them fit a little bit better. I have one of these left over. One of them wasn't really up to snuff quality control wise, but I can't get a pin to stick in number 106 right there, but I don't really care. I have extra. These are extras. These are extras because of my goof earlier, and I have got extras on cars that I'm not using right now. Yeah, so that takes care of all those supplies. Of course, shrink tubing, out of electrical tape now. It's not an essential thing for me to travel out and venture to get more of. You'll use the daylights out of a heat gun. Of course, this cheap multimeter, it was enough. You don't really need anything, amazing, but hey, you know what? If you have a really nice multimeter, you're probably more intelligent than I am. These things I didn't really use at all, but I can someday. I'll need one of those. I'm sure of it. I'm glad, and I have the crimpers that go with it too. I'm glad I have extras and spares of different kinds of connectors. I used this nice little case that was included with the Sheridan Engineering kit.
I love it.
To put all my spare connectors, and you see I have extra ECU pins so I can do more repairs in the future if I ever have to other projects. I'm just really glad to be able to be prepared with this stuff. I know that I told you to, rely on someone else if the part's available. Well, you can do that, and you can solve your one problem, but I'm glad that I have all this extra and spare stuff, and that my tool collection has expanded, because now I can do this for an entire lifetime, and these won't be the last times I'll ever be facing this kind of an issue. I'm sure I'll go through this again and again. You know what's in my driveway. So that's a quick rundown on the tools. I can gloat about this job now. I can finally say I did it. I can check this right off my bucket list. I'll finally have a clean airflow signal, grounded RF shielding, a noise filter, a new wideband cable and sensor, working gauges, no more bullet connectors, no more engine whine in my stereo, no more loose or broken ECU pins shorting out, clean data logs with good complete data in them. It's crazy that this car ever did anywhere near as well as it did with the old harness that was in it before. We all know it was mechanically sound, but it was just running on prayers, really. I'd trust it to go on a road trip all by itself now. I'm grateful to ECM Tuning and everything that they've contributed to this project. I hope that now with this new engine harness in it that I'll be able to make a better representation of really how awesome it is and all the other cool things that it can do. I appreciate the fastest delivery of a wideband controller I've ever bought, especially during these times, and I really appreciate you and the impact that you've had on all the DSM enthusiasts out there like me over the years. Tom, Robert, Chad, Jamie, Jason, all the people who let me complain to them about this job and who still said nice things about me at this time when I was away, thank you. I hope you've had as much fun watching this video as I did making it. Anybody that's considering doing a wiring job like this, hopefully this serves as some kind of a piece of reference material or a guide or something just to set your expectations. This is my first time doing it. I'm really happy with the results. But I hope all of you are safe, happy, and healthy at home with your families at this weird time that we're going through. And there's not really a lot more I can do on this topic, so that's next. If you'd like to contribute to my cause, check out the links in the description for my Patreon page, where you can get behind-the-scenes action and early access to new uploads. Rojo Del Champa made a brand new audio track for all my patrons, and to take us out of here. Until next time, stay tuned.